Hey geometry class, this is our section 7.3 lesson. We're going to be using similar right triangles. And here's our objective. It says to understand the properties associated with altitudes within right triangles. So if y'all remember what altitudes are of triangles, well, we'll get into that if you don't. And then all of this that we'll be looking at in this whole chapter is all about right triangles. So we're not going to vary from there at all. So let's go ahead and get started. So here is the definition of altitude. Okay. An altitude of a triangle is a straight line through a vertex and perpendicular to the opposite side. Okay. So for this altitude right here that is drawn in with a dotted line, this is our altitude for the side of our hypotenuse going through the right angle. And there are properties about altitudes of right triangles. And it says if an altitude is drawn to the hypotenuse of a right triangle, then the two right triangles formed are similar to the original triangle and to each other. So as you can see, it broke apart. This triangle right here is in red, ACD. And then this triangle right here is blue now. And these three triangles that you see pictured right here are all similar triangles. So the first thing, before we move to a few of our exercises, I want us to look at this. I want to look at sketching the three similar right triangles that we see in this given triangle. And then we are going to sketch them in a way that all the angles are correspond to each other. So we're going to have to change each triangle's orientation. So we're not going to keep it as this figure did here. We're going to change all of the triangles and make them look the same, just they're all going to be getting smaller for each triangle as we go. All right, so here it is. We are going to draw. I'm going to do my best. I'm going to draw the original figure here, not to scale at all on this page. Okay, so here is S, T, R. Okay, now I'm going to draw this triangle orientated differently. So just draw another right triangle, a little bit smaller than the previous one because it is smaller than the previous one. And then write your letters in for each of the angles, okay? So our right angle here is labeled U. So right here, we're going to write U. This angle right here is bigger than this one. So we're going to write T right here and then R right here. And now draw a third triangle. It's a little smaller again. And again, on this small right triangle, it has a right angle right here. It's again at U. And then this angle S is bigger than this angle down here at T. So we're going to label this S and this T. And there you have it, our three right triangles with the same orientation. And now from redrawing these triangles with all the same orientation, we're gonna it's very easy to identify the similar triangles that we have here. So just go in order from left to right. I'm going to state that, well, this triangle, and I'm just going to go in a clockwise motion here, starting with R. I'm going to say R, S, T, is similar to triangle RTU, and that's similar to TSU. And that is what I wanted you to do on this page right here. That is what this whole thing was talking about. Okay, so let's move on. Here's our exercise 1, and we're going to identify the similar triangles and find x. To first find the similar triangles, I'm going to draw out the two triangles on the inside of our right triangle oriented the same way as we have the original outside triangle, the EGF. So right here, I'm going to, well, draw the medium-sized one because we already have drawn the bigger one, okay? And I'm going to label that. Well, here's H, so label this right angle H. And then the bigger angle right here is G, and the smaller angle F. I'm going to draw that a little bit better, hopefully. Whoops. That's a little better. Okay, now let's draw the smaller triangle oriented the same way. Okay. And again, our right angle is here, and our bigger angle of the two acute angles here is E. Oops, let's label that E. And then the other one is G. Okay, so now from these, drawing out these two triangles, we can see pretty clearly the three triangles that are similar that we're going to name. So triangle here, E, just go around clockwise or counterclockwise. Go, and start with the same angle each time. So this one's going to start with E, this one's going to start with G, and then the next one's going to start with E. Okay, then I'm going to go around it. E, F, G, and that's similar to triangle. G, F, H, and then that one's, they're all three similar to, let's see, E, G, H. So there is identifying the similar triangles. This statement right here, you don't have to rearrange it saying triangle EFG is similar to GFH and GFH is similar to EGH. And then you don't have to name all the combinations. Just state the three similar triangles in a similarity statement like this. Okay, now to find our x value. How we're going to do that? Well, let's label these sides of our right triangles here. So GH, that is our x, and GF, see, do we have a GF? Yes, we do. GF right here is 4. And then we don't have an HF value. That's part of this whole length of 5. And then over here we can label EG, that is 3. And then HG, again, that's our X value. Okay, so from these three similar triangles that we have, just remember back to whenever we were looking at similar triangles in the previous chapter, and use similar triangles, the ratios of corresponding sides, to set up an equation to solve for x. So what I'm going to do here is I'm going to take this side and put it over this one. So 3 over x. And then set that equal to This whole side is 5, so 5 over 4. I can do the same thing with my smaller right triangle. I can say, let's find x on the smaller triangle. Well, the two sides that we would be comparing in each triangle will be different. So for this one, I would say 4 over x, because those are the two corresponding sides, is equal to 5 over 3. And then next step, you will see it didn't matter which way you actually, which triangle you actually choose to find x, to help you in finding x. They're both going to be the same thing. So cross multiply, we get 12 equals 5x. And here again, we get 12 equals 5x. So x in both cases is going to be 12 over 5. Okay, so that is how we're going to do uh, these triangles. And then I'm going to show you here in a little bit a couple of theorems that will help us in doing the same similar triangle, identifying how to find your x value in triangles drawn pretty much exactly like this. All right, let's do it again. It says identify the similar triangles and find x. So identifying the triangles. Again, I'm going to draw the two inner triangles oriented the same way as the outside triangle, LJM. Okay, there's one. There's another. Okay, and then let's label this. So my right angle for both of them are going to be labeled K. And then for this middle-sized triangle, my bigger angle here is where you see M. So M, and the other one is J. And then over here, my bigger angle is L, and then my smaller one is M. So L and M. Okay, now we have them oriented all the same direction. And I'm going to go ahead and label my sides of my triangle. So KM is X here and here. Uh, this side, JM is 12. And then LM is 5. Okay. Now, let's identify the similar triangles by stating their names. So triangle, let's say JLM. That's going to be similar to JMK. JMK. And then that is similar to MLK. Okay, there's our similarity statement that we want. And now let's identify, well, find X, not necessarily identify. Okay, with setting up our corresponding sides in a ratio and then set equal to each other. So here I'm going to say 13 over 12 is equal to 5 over x. Now we don't have to go over here and do anything with the smaller triangle. I just did the smaller triangle so we can identify the the three similar triangles. But here we have the ratio set up that we need, and now solve for x. So cross multiply, we get 13x equals 60. And now solving for x, got to divide both sides by 13, so we get 60 over 13 as our solution. And we're done with that one. Now here are the two theorems that I was talking about a little earlier. They're called geometric mean theorems. One is called the geometric mean altitude theorem, and the other one is called the geometric mean leg theorem. This is because in this theorem, we are usually looking for the leg of our triangle, or we are given the leg, or sorry, the out. Now, here are the theorems that I was referring to a little earlier. They're called geometric mean theorems. This one is called the geometric mean altitude theorem, and that is because you'll see that we are either given information, we know what the altitude is, or we're looking for the altitude. And this theorem here is going to be helping us find the altitude, or find another side of our triangle that we have here using the altitude. Okay, and then the geometric mean leg theorem, same way. We are looking for one of the legs of our right triangle, and that this theorem right here is going to help us in that. All right, so let's look at the altitude theorem and put it to use over here in example 3. So this one right here, it says the geometric mean. If you've never studied what geometric mean is, then the geometric mean of two numbers, like if I say 4 and 5, the geometric mean of 4 and 5. If I want to find that, then I'm going to set up this ratio at an equation right here. If I want to find the geometric mean of 4 and 5, this is how you do it. You say x over 4 is equal to 5 over x. And then you cross multiply, get x squared is equal to 20, and solve for x. X is equal to square root of 20. And we can simplify that or turn it into a decimal number, but that is what the geometric mean of 4 and 5 would be. So these theorems go along with that there, the geometric mean of two numbers. So this geometric mean altitude theorem is the geometric, to find this altitude, it's the geometric mean of these two sides of our right triangle here that make up the whole hypotenuse. Okay, so many times you will be given each of these segments, like we are in this exercise here, and how we find the altitude is we follow this right here. See how this right here is CD, and this is CD, that's referring to the altitude. And then BD is this length, AD is this length. So we take the geometric mean of these two numbers, is what we're doing. Let's find it. Let's find x in this example. So we're going to say 3 over x is equal to x over 12. And then solve for x. We get x squared is equal to 36. Take the square root of both sides. We get 6. And that's what x is equal to. And there, we're done. We found what x is equal to. So that's how you use the geometric mean altitude theorem. And then the geometric mean leg theorem, it's similar, but why it's called the leg theorem is because many times we are either given information about one of the legs or we're trying to find one of the legs of our outer triangle, the biggest triangle that we have. So how we do that is, okay, notice in this right triangle, we have CB here and CB here. So CB is the leg usually that we are trying to find. And then we will be given AB and DB. So the whole length AB and the smaller length DB. Okay. And then the other leg theorem, this is for the shorter leg, finding CB. But if we're wanting to find the longer leg, AC, then this is how we do that. We have AC here, and then AB again, the whole length of AB, and then AD right here is the longer portion. Notice that we had AB over here and then the shorter portion of this whole segment, but this time it's AB, the whole length here, and then AD, the longer length, AD, not the shorter one. All right, so let's use the leg theorem to help us in finding what x is on this triangle. Okay, so following this one right here, because we have the longer leg in our triangle, we're going to say, so the AB, which is the whole segment length, so 4 plus 1, which is 5, or you can write 4 plus 1 here, over this side here. See, AC, the side length that we're looking for. So x is equal to AC, which is x, over the longer side, the longer segment of these two. Either 1 or 4 is what's going to go under here. But since we are looking for the longer segment, it's going to be 4. Now, do the cross multiplication here. Oh, I just did 4 and 5 up here. If you have that still written down, you can use that as your work. But here, cross multiply, we get 20 equals x squared. And as we found out earlier, uh, this is going to be square root of 20. Or in simplest radical form, it will be 2 square root of 5. And that is our solution here. Okay. All right, now it says in this problem, it says, find the value of the variable, write your answer in simplest radical form. On this one, what I want to do real quick is kind of combine the geometric mean theorem and what we know about these similar right triangles that we have here, and just kind of use both of them. Here, I can orient this triangle right here in a different way because we are looking for what y is equal to. I'm going to draw that in over here. So this would be a right angle, which is here. And the side opposite of that is our y. And I'm going to call this S, R, Q. And then label the sides that you know. I know this is y, and then this right here is 3. Okay. You can use similar triangles here to help you in figuring out what this value of y is equal to. Or you can just go back to the geometric mean theorem and know that, okay, it's the geometric mean leg theorem that we are looking at. We'll say 9, the whole length of this hypotenuse, 9 over the smaller, this small triangle's hypotenuse, which is y, and that's equal to, so let's say um, this outer triangle's leg is y over 3. And if you got that, we're using similar triangles still. So we're saying 9 over y is equal to y over 3. Okay? And that is our geometric mean theorem right there. So cross multiply, we get 27 equals y squared. And then that there is same thing as saying y is equal to square root of 27. If you simplify that, that simplifies to, or the 27 breaks out to 9 and 3, because that's what we just multiplied. Take the square root of 9, we get 3 square root 3. And there we go. That's what y is equal to. So again, let's look at another one. We're going to use the geometric mean to find the value of y. Then we're going to write our answers in the simplest radical form. Using the geometric mean leg theorem here, because we are finding the value of a leg, not the altitude. How we do this is we start with the whole length of our hypotenuse over this triangle's hypotenuse, which is x, equals the length of this leg of our big triangle here, which is x, over the smaller side of our triangle's leg that I just highlighted in red here, 5. And there you go. Now just the next step, uh, do the cross multiplication to get this, and take the square root of both sides, and we get square root of 90 equals x. And then it says write your answer in simplest radical form. So this right here can be split up. We'll call this x. You could split that up into 9 and 10. Take the square root of 9. You get, get 3 square root 10. And we're done. Okay. I'm actually going to show you one more of these, and then I expect you to do these last two as your lesson quiz, and I'll give you some hints on those. Well, let's do number 7 real quick first. So number 7, um, we're asked to find the values of the variables in these 3 exercises, and this is our variable here. We're looking for a. And what I'm going to do real quick is I'm going to orient this triangle. Maybe, nah. I'm just going to highlight it. Okay. So we need to focus on this triangle right here compared to our our big triangle that we have here. All right, so finding what A is equal to, what I'm going to do is use the geometric mean leg theorem, because we are given a leg. We don't know anything about the altitude. We're not asked to find anything about the altitude. So using that geometric mean leg theorem, we're going to say this whole length of this hypotenuse, 12, over the hypotenuse of this triangle, which is 6, is equal to the leg of the big triangle, 6, over the leg of our small triangle, A. Okay, now do the cross multiplication. Get 12A is equal to 36. Divide both sides by 12, and we get 3. There we go. Now, some hints on numbers 8 and 9. Well, number 8, I say go back to number 3 in these exercises and take a look at that this one is a lot like number 3. So, similar to number 3 in these exercises, so look at that. And then this one right here, number 9, is just very similar to number 7. So take a quick look at that and compare the two of them and follow how I did each of these to help you in figuring out these variables that you're asked to find here. Okay, and that's all I have for you. Goodbye, everybody.